Hello, thank you for being here to another exciting, we'll call these quarantine lectures. As more people join us, thank you for completing your test too. I appreciate that's very helpful. I'm going to grade them and hopefully I'll have your scores posted sometime this weekend, hopefully no later than Monday. So I'll get that grade to you as soon as possible. So let's go ahead and start our lecture for today. As people start sending in, we'll just jump in. If for some reason, someone who can attend today's lecture live, just let them know that they can watch it on YouTube. I'll post it in about an hour after it's done. We're done with the recording. All right, let's go ahead and go into today's notes. So I sent you out a announcement that it would be on this week's module, and I updated the module last night, and I included a Word document and a PDF file so that you can just follow along and not worry about writing those lengthy problems. However, I noticed when I was logging onto Zoom to give you the link that I never opened or made the module for the week visible. So you might have not had access to it until I sent the announcement. So make sure you get that done. If not, just make sure you give yourself some space to write down the problem after we're done working it out. Well, after class, you can write down the problem, the question. Okay, let's go ahead and get started. So I'm going to mute all of you. I'm going to go ahead and share my screen. All right, so we're going on to our notes for today. And we're trying to dip our toes into some stats material. So hopefully we can go in, you're in really good shape. So in our 2.5 notes. So we're going into quartiles. So before we go, we continue. Recall something we've learned in the past. So we learned some measures of central tendency. We learned about the mean, the median, and the mode. The mean is your average, right? Your median is the middle number, most middle number, and your mode is your most common number. Well, to continue with this section, we have to be able to recall what a median is. And it just means the most middle number. I have to list them in order, right? So I have to list them in order from smallest to largest. And I need to find the most middle number. And that's how you go about finding the median. We're gonna have to apply this for this section. All right, so let's go ahead and define quartiles. Quartiles, if we were to list all of the data in ascending order, that means smallest to largest, we can split it into even sections called fractiles. One type of fractile is a quartile. And this is when we split up our data list into 4 even parts. Note, the date needs to be listed from lowest to highest. That should be data, not date. Definition of quartiles. The 3 quartiles, quartile 1, 2, and 3, are divide and order data set into 4 equal parts. About 1/4 of the data fall below the first quartile. About 1/2 of the data fall on below the second quartile, and about 3/4 of the data fall below the third quartile, quartile 3. So let's say this rectangle is all of our data. And think of these quartiles as fractions. We have now split our data into 4 pieces, right? So each one of these middle stripes that we use to split it up with, that is our quartile. So we can go ahead and let this be quartile 1, quartile 2, and quartile 3. That's what it's saying below, how it splits it in half. But really, we really have, in a sense, we have fourths, right? We have a fourth here, a fourth here, a fourth here, and a fourth here. Let's go ahead and do an example so we can see how to do quartiles. Example 1. Each year in the US, automobiles commuters waste fuel due to traffic congestion. The amounts in gallons per year of fuel wasted by commuters in the 15 largest US urban areas are listed. Find the quartiles. So here are the numbers we have. We have 20, 30, 29, 22, 25, 29, 25, 24, 35, 23, 25, 11, 33, 28, and 35. And I want to find these quartiles. I want to find Q1, Q2, and Q3, just like we have above, right? Okay, well, to do that, I need to go ahead and list these numbers in order from smallest to largest. And I need to be able to split them into fractions from there, or our data into pieces. So let's go ahead and do that. Let's do that above. Let's list them in order. And this takes some time. So what's our smallest number? I see 11, so I'll write 11. And then we have 20. Then 22. And then 23. 24. 25. 25, 25. 28. 29, 29. 30, 33, 35, 35. Oh, it really fit. Okay, and I want to find my quartiles. First, start with quartile 2, because I can find it by finding the median, right? So first you want to find quartile 1, which is your middle number median. Well, let's see how many data entries we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 of them. So let's go ahead and find the middle number. So we go ahead and divide 15 by 2. And we get 7.5. So it would be the middlemost number. It would go ahead and be 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. It's that third 25. We round up. So this would be our Q2. You write that down so you have it written. Round up. And so the 8th one is our number. So there we have it. We have Q2. Q2. Okay, now let's go ahead and focus on our first half of our data set. So let's focus only on these numbers. Okay, from that set of numbers, I want to find the middlemost number again. I want to find my median. All right, so our middlemost number, you can count it off and count to the middle, or you can just divide by 2 and round up. We end up getting that our middlemost number is 23. And that middlemost number now becomes Q1. So let me write down what we did. Now we need to find Q2. So we find the middlemost number of our first half. So we divide our numbers by 2 and we round up. So we have 1, 2, 3, 4, 5, 6, 7. 7 divided by 2, we get 3.5. And you round up, we get 4. So it's our fourth number. All right, lastly, you want to take a look at our second half to the right of Q2, not including Q2. And we want to find the middlemost number. So because it's already split in an even amount, I know, again, it's going to be the fourth number. So 1, 2, 3, 4, bingo. I know 30 is going to be my Q3. So 30 is our Q3. So we have found our answer. Our question is to find the quartiles, right? Find quartiles. We have done so. Our answer, our Q1, we have listed as 23. Our median, our Q2 is 25. And our Q3 is 30. Now remember, if there's ever an even set of numbers, we're gonna have a tie between two numbers as to which is the most middle number. You want to find the average between those two numbers. So here are some calculator operations. Now, this is for a TI 83 or maybe a TI 84. Those are those very pricey calculators. I am not making you work with the calculator because you might have a class where maybe they emphasize Excel or maybe they emphasize StatCrunch or some other type of software. So don't worry about the calculator operations. But if you do use a calculator, you have them on your notes from your previous class. Now, when you're looking at these problems, sometimes we'll have very lengthy problems to work with. And for such case, don't worry too much about what you're going to do for such a situation. Yeah, it will be lengthy if you do it manually, but keep in mind that when you go on to your statistics course, you will use something to help you. You're going to either use a calculator, Excel, or StatCrunch, depending on what they want you to use, what your professor prefers. So when you have a problem like this, when you have 25 pieces of data, wow, that would be a lot of work to find Q1, Q2, and Q3. Luckily, we can go ahead and use our data, or I'm sorry, our software. So we'll go ahead and skip this one because it might be too much to do manually. But know that software will help you for this for sure. For example, if you use Excel, you can enter these numbers vertically into a row, and you can go ahead and tell Excel to give you the quartiles, and it'll tell you which is quartile 1, 2, and 3. Let's continue with the section. With definition of the interquartile range, also referred to as IQR. The interquartile range IQR of data set is a measure of variation that gives the range of the middle portion, about half of the data. The IQR is the difference between the third and the first quartile. So we have this little formula here. IQR is Q3 minus Q1. The IQR helps identify if any outliers in the data. Outliers are found then the data value is less than Q1 minus 1.5 times IQR, or when the data is more than Q3 plus 1.5 times IQR. So these formulas will help us find outliers. Outliers are numbers that are too small or too big for your data. And this is helpful. A good idea or a good example I always think about is when we think about how much people in the neighborhood or in a city make. It would be very different if we have everyone who makes, a typical middle class amount of money, but would if you throw in like the Amazon fee, oh, that would definitely change the numbers up and skew them so that they're higher. So in such case, you want to make sure we're aware of any numbers that are too high, like the CEO of Amazon's income, or something that's too small. All right, moving forward. We also use quartiles when creating a box and a whisker plot or a box plot. This type of graph is helpful because it highlights important features and also gives you an idea if the data is skewed in any way. So these are our guidelines to draw a box and whisker plot. So I stole this from your book, but it's a very good image because it tells you everything in step by step and it gives you a picture. And your book is very good about giving you a summary of all the steps. So in your book, this is from section 2.5. It's from page 105. Let's go ahead and go over how to draw a box and whisker plot. So 1, you want to find the 5-number summary of the data set. 2, we want to construct a horizontal scale that spans the range of the data. 3, plot the 5 numbers above the horizontal scale. 4, draw a box above the horizontal scale from Q1 to Q3 and draw a vertical line in the box of Q2. That's this vertical line right here. And 5, draw whiskers from the box to the minimum and maximum entries. Okay, so something we haven't gone over yet, but it's just a quick addition. A 5-number summary. Find the 5-number summary. The 5-number summary is our minimum number. We already know how to work with Q1, Q2, and Q3, and we're going to add the maximum number. So the minimum and the maximum are added to our quartile, and that gives us what's called the 5-number summary. All right, let's go ahead and do example 4. Draw a box and whisker plot that represents the data set in example 1. Hint, you already found Q1, Q2, Q3 in example 1. So let's take a look at example 1 and see all those numbers. Let's remember what our story is. In example 1, we talked about the US automobile commuters waste, how much fuel they waste. And we have the gallons they use in commuters, right? We have numbers that go from, if we have our list of numbers above from lowest to largest, we have 11 through 35. And our quartiles are 23 for quartile 1, 25 for quartile 2, and 30 for quartile 3. All right, using those pieces of information, let's go to our example 4. Draw a box and whisker from example 1. So let's recall from example 1 that our minimum, our smallest number was 11. Our quartile 1 was 23. Our quartile 2 was 25. Our quartile 3 was 30. And our maximum, our largest number from our list is 35. Okay, so let's go ahead and draw a number line so we can include all of these numbers. All right, so we have a list to follow that we have above, right? I want to find our 5-number summary. This right here is our 5-number summary. All right, to construct a horizontal scale that spans the range of your data. So I need to make sure that in my number line, I have numbers that include 11 through 35. So why don't we go by 5s? And maybe start with the number 5. So you can do 5, 10, 15, 20, 25, 30, 35, 40. Okay, we drew a horizontal line that fits all of our data. 3, plot the 5 numbers above the horizontal scale. All right, so just like we see right here, we have our minimum entry, we have Q1, we have Q2, we have Q3, and a maximum. We want those 5 pieces. All right, so our most smallest number is 11. So I'll go ahead and mark it here. Our Q1 is 23. So I'll go ahead and draw a line where 23 should be and label that Q1. Q2 is 25. And Q3 is 30. Q2, Q3. Let's draw a box. And lastly, I want to label my maximum. My maximum is 35. That's step 3. All right, step 4. Draw whiskers from the box. I'm sorry, step 4, draw a box above the horizontal scale from Q1 to Q3 and draw a vertical line in box 2. We get a little box right there. All right, so step 5, draw whiskers from the box to the minimum and maximum entries. So from our box, we're gonna draw a line connecting our box to our whiskers. There we go, we have drawn a box and whisker, or a box plot. Continuing on, the standard score. This is how we measure the number of standard deviations away from the mean. Recall from the last section when we learned about the empirical rule, where the number of standard deviations can tell us the percent the data falls under. The empirical rule limits us to the standard deviation being 0, 1, 2, and 3. But what if the number of standard deviations is not a whole number, rather a decimal? Or if the number of standard deviations is more than 3? Well, there is a way to measure such cases, and we use what's called a z-score. A z-score should be your best friend. Let's define a z-score. Definition of a z-score. The standard score, or z-score, presents the number of standard deviations a value x lies from the mean mu. To find a z-score for a value, use the formula, and this is our formula. Z-score is equal to the value minus your mean divided by standard deviation. And here we have our notation, x minus mu over sigma. Let's do an example. The mean spread of vehicles along the stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speeds of 3 cars traveling along the stretch of highway was 62 miles per hour, 47 miles per hour, 56 miles per hour. Find the z-score that corresponds to each speed. Assume the distribution of the speed is approximately bell-shaped. All right, so it's telling us some general rule, some information that's like a standard, and then it's throwing in something we want to compare it to. So the beginning part reads, the mean spread of vehicles along a stretch of highway is 56 miles per hour. So we know that's going to be our mean. And it continues on to say, and this with a standard deviation of 4 miles per hour. So also tells us something important, that we have a standard deviation of 4 miles per hour. Now we have something to compare it to. You measure the speed of 3 cars, that's new, along the stretch of highway at 62 miles per hour, 47 miles per hour, and 56 miles per hour. So the numbers we're going to compare them to, those are going to be our x's. So we have three x's to work with. We have one is 62, one is 47, and the other is 56. And we want to find the z-score that corresponds to each speed. Recall, we just listed what the z-score is. We said the z-score is, we have it right above, the z-score is x minus mu over sigma. Do we have all these pieces of information to answer our question? Yeah. We have our x, which is these numbers we just found. Those are our x's. We're going to do this 3 times. We also have our mu, minus mu. Our mu is 56. And we also have a standard deviation. Divided by our standard deviation, we're going to divide by 4. Okay, let's go ahead and write down our formula for each one and work it out. So our first one we're going to work with is that speed of 62. And we want to find the distribution that it falls along our bell-shaped curve. All right, so our formula is z is equal to x minus r mean mu over standard deviation. All right, so this is defined as our z is equal to our x, which is 62, minus our mu. We said our mu is 56, minus 56, divided by our sigma, which is 4. Let's go ahead and take our calculator. So 62 minus 56 gives us 8. Divided by 4, 8 divided by 4 is 2. That's our standard deviation for, our z-score for the first one. Z is equal to. Let's do 47. So again, our formula, it's always good to write a formula so it helps you remember. Z is equal to x minus our mu over our standard deviation. All right, if we fill these pieces in, our x, well, we said our x is 47, minus our mu is 56, divided by our standard deviation of 4. 47 minus 56 gives us -9. And -9 divided by 4, that gives us, I'm using a calculator for this, -2.25. That's our answer. So we have a z-score of -2.25. All right, let's do that last entry. 56. Let's start again with our formula. Our formula is z is equal to x minus mu over sigma. My x in this case is 56 minus my mu. Our mu is always 56 for this one, right? We said our mu is 56 divided by standard deviation of 4. 56 minus 56 is 0. 0 divided by 4 is 0. So we have a z-score of 0. So what did we just find? Let's recall our empirical rule. So I'll start from the very beginning. Our empirical rule told us that if I have a bell-shaped curve, I have some information based from the mean. So our mean, our mu, your average, is 0 standard deviations. Now I can move right and left the number of standard deviations. So we can go ahead and move 1 standard deviation to your right. So our mu plus the standard deviation and our mu minus 1 standard deviation. And that's a special percent that falls under that range. We can also move to the right 2 standard deviations So that'd be mu plus 2 standard deviations. You can also move to the left, mu minus 2 standard deviations. And we go up to 3. We can go ahead and move to the left, 3 standard deviations. So we're going to take our mean and subtract 3 sigma. We're going to take our mean and add 3 sigma. And we said that everything falls within 1 to 3 standard deviations. Well, not everything, but we're talking about. And in general, we said that plus or minus 1 standard deviation, we said that 68% of our data falls in that range. Plus or minus 2 standard deviations from your mean, we said that 95% falls within that range. And plus or minus 3 standard deviations, we said about 99.7 falls between that range. So this is our empirical rule that we learned from our last meeting, which was a very lengthy section. But what we're saying here, your standard score, your z-score, is we're saying, what if we have a number and this number falls in between? It's not exactly 1, it's not exactly 2, well, it's not exactly 0. Where does it fall? Well, for that such case, when your number is not between 0, 1, 2, and 3, we use a z-score. So it's a number of standard deviations, but it's not a number like 1, 2, and 3. It can include decimals. That's just your standard deviation. Where decimals are okay. That's all that's saying. So let's go analyze what we found in example 7. So we found these speeds and we want to compare them to our average speed, which is 56. So our first one that we worked with was 62. And we said that 62 falls 2 standard deviations, plus 2 standard deviations. So if we look at our empirical rule, that would be somewhere right here, plus 2 standard deviations. That would be our first one. Cool. Now, if we take a look at our second example, 47. 47 fell between 47 found at negative 2.25. So we're going to move negative 2 standard deviations and a bit more. So this one falls somewhere over here. We're not too sure, it's a decimal, but at least it gives us an idea of where the position is. And for 56, we got 0. Now remember, your mean, your average is 0. So that just means that our third one is falling at our mean. It gives us a spread and a position along our bell-shaped curve. Given that we have a bell shape, we can do so much, and that's pretty much the basis of our course. Now, knowing where it falls in terms of a bell-shaped curve and in correspondence to your mean, we can know in the future, we can know a percent of something happening, or we can know what that number is according to a percent. It can tell us quite a bit. But it's really important that you understand your mean, your standard deviation, and your z-score, because having a good understanding of those 3 things will make it so that future sections will be much easier to understand. So on Canvas, I will go ahead and post this lecture as it's written. So you can go ahead and add it to your notes if you'd like. I'll also post this this lecture on YouTube. So in case you want to go ahead and take a look at it again, if something seems like you want to see it again or you forgot what happened. I will also answer any questions. I posted a general discussion board, so you can go ahead and post your questions. I'll answer them. If someone posted a question, feel free to answer them yourself. It's just so that we can ask those questions that I know we might not be able to ask in class. All right, so that's it for today's lecture. That summarizes 2.4. What I hope to do next week, our second to last week of lecture, I hope to give you insight of important topics that you'll see in your stats course. I also would like to start reviewing. So along with next week and week 18, which is our last week, I want us to review. We covered a lot of stuff. We covered a lot of techniques in algebra that you'll see in your statistics course. And I want you to be prepared for your final. We're 2 weeks away. We're 2 weeks of coursework away from it being your finals week. Our course ends on May 21st. So we're getting close to ending the semester. All right, before I log off, are there any questions?
That wasn't our final yesterday?
No, that's test 2.
Okay. Thank you.
Your final, yeah, your finals will include everything we've covered, but I'll give you a solid review and we'll review and we'll go through that review together. I'm not just gonna throw you into the wolves at the end. No, we're gonna spend a lot of time reviewing so that when you get to your final, you'll have resources, you'll have your review done, and you can just go ahead and work through it. I hope to not make your final timed, so you can go ahead and, I know there's a lot of distractions at home. I don't know if you have children or siblings, and sometimes it's really hard to just be sitting down and focusing for a set of time. So it won't be timed. And I'm also not proctoring in a sense because there's virtual proctoring available and I'm not proctoring. So you have your resources, you have our notes that we've done, you have the review, so you'll be in good shape to do super well in your final. And I want you to do super well. All right.
Yeah. Thank you.
You're welcome.
Do you also teach statistics or you just do pre-statistics?
I also teach statistics. I'm teaching in the summer, but not in the fall.
Oh, so okay, so you're teaching statistics only in the summer? Okay, that's good enough. That's good enough because they sent us an email to start signing up, and I'm not really good at math, but the way I'm learning here, I like it, and I was just asking. That's fine.
Yeah, feel free to sign up. It's going to be a core rec course, so I spent a lot of time reviewing a lot of things that we did here.
Cool.
So we'll see how that works. But yeah, I'm teaching in the summer, and it's not a thing of what I only teach. It depends what they give me because I'm part-time. I just get whatever left over. So
cool. Thank you so much.
Yeah. All right, you're welcome.
Good day.
All right, so if there aren't any more questions, we'll go ahead and end it here. Just to let you know, I do teach statistics in the summer in case you want to go ahead and take that with me in the summer as well. All right, well, have a nice weekend. I'll see you on Tuesday. Bye-bye. Thank you so much for being here with me.